Is it visible now?
Yes, so now it's fine.
Okay. All right. So you need to determine the RT here. So if you look, R1 is in series with R2 and which is in series with R4. This R3 will not contribute to anything for the simple reason current, if you apply a voltage here, then the current here, it flows like this and it will not branch out in this direction because this end is open circuited, right? So the current will start flowing only through this particular path. So the answer is 12.1 ohms. So 1.2 plus 2.7 plus 8.2 ohms, right? So, okay, the next problem. Now, can you give me the answers for this? Okay, the answer is 2158. One of you have given. All right. So it is 2158. I'll quickly tell you how to solve this. So the current, if you apply a voltage between these two terminals, the current will start flowing through this and it will flow only through this direction and it will not flow through this direction for the simple reason this terminal is open. Likewise, the same current as it comes here, it will enter through this direction. It will not flow through this direction because this end is open. So the current will actually flow through this particular path only. Okay, so that is how you solve. And this particular problem also similar way, it is total equivalent resistor is 10 plus 33 plus 56 will be the answer. 47 ohms will not contribute to your total equivalent resistor for the simple reason the current that travels here will not branch into this particular path, but rather it will branch only through this particular path. Hence, the total equivalent resistor is 10 plus 33 plus 56 ohms, which is 99 ohms. Now coming to the next circuit, similar circuit again. Here also, yes, what's your doubt? Somebody has raised your hand. What's your doubt, Arnab?
Yes, sir. Good afternoon, sir. Sorry for bothering you. This is not relevant to the topic you're teaching right now, but multiple people are trying to join the meeting right now. It's showing that you need to give them permission.
Mhm. I'm not getting any notification for permission, by the way.
So it's just showing hey and their name. Someone in the meeting should let you in soon.
Okay, maybe I'll allow you to, yeah. Yeah, I have made you the presenter, so you can allow them so that I don't get disturbed in teaching.
All right, sir. All right, sir. sorry. I'll do that. Thank
Yeah,
you.
okay, okay. All right. So coming back to the topic. Uh, so here again, this resistor will not contribute anything to your total equivalent resistor. So it is 2.2K, 0.82K plus 3.3K. So the total equivalent resistor is 7.52 ohms. So 2.2 plus 0.82 plus 1.2 plus 1.3, right? So all these four resistors. Now let's do other type of problem. This is problems related to series resistances. Very simple. Now again, these are problems
Okay.
related to, yes, these are problems related to series voltage sources. You have to find out what is VAB. You have to find out what is VAB. So how will you do? You will have to apply Kirchhoff's voltage law along this particular path, right? So you apply Kirchhoff's through this particular path. Uh, how will you write? It is minus and plus, right? So if you encounter minus and plus, we write as plus 12. right? So it is plus 12. Plus and minus is minus 18. And then minus and plus is plus 6. And then plus and minus is minus 12, right? So your total VAB. So VAB means it is like putting a battery like this, and then with A as this terminal and B as this terminal. So VAB. So again, when you travel here, it will be plus VAB. So plus VAB will be equal to, oh, okay, this pertains to, I think, some other problem. Yeah, to this particular problem actually. Okay, so it's slightly reorganized. So this voltage equation corresponds to this particular circuit. So VAB plus 12 volts minus 18 plus 6 minus 12 is 0. So therefore, VAB is 12 volts. Now coming to the next problem here, you have to find out what is the value of R and what is the value of E. Again, you travel along this particular path, the closed path. Yeah, you can travel through this particular path like this. So the equation becomes traveling like this. It is minus to plus, it is plus 16, right? So it is plus 16. No, it is a drop, right? So it should be minus 16. So it is minus 16 volts, and then it is plus 10 volts, plus 10 volts, and then it is a drop again. So this problem seems to be something else.
And even if it's a drop, it should be plus
Yeah,
only,
it
right?
should be
Because the
plus. Yeah,
sign is
yeah.
written.
Just hold on. Okay, so now let's do this. Yeah, so starting from this particular point, just to travel around this particular loop. So it is plus 16, plus 16, plus 10, plus 12, plus 4, minus E equal to 0. So which means E will be equal to, so how much? 16 plus 10, 26, 26 plus 16, 36, 42 will be the voltage across this particular E. And once you know the total voltage here, so 42 is the voltage of this, then you have to find the total current here. So if you want to find the total current, combine all the voltage sources here. So if you combine all the voltage sources, and then you know what is the you can find what is the total equivalent resistor divided by the current. You can find out what is this particular resistor is. Now
Oh my God.
let's solve this problem. We are going to solve only problems today. So determine these unknown voltages, that is V1 and V2, you need to find out. Now, in order to find V1, you will have to follow this particular path. You have to follow this particular path. So it will be plus 24 and minus 10 volts plus E1, V1 equal to 0. So plus 24 minus 10 minus V1 equal to 0. So V1 is 14 volts. If you want to find V2 here, then you have to apply KVL in this loop. So KVL in this loop will be, it will be plus 10 minus V2 plus 8 will be equal to 0. Plus 10 minus V2 plus 8 equal to 0. So V2 will be equal to 18 volts. So by this way, you can apply KVL in these loops. Now, coming here, this particular problem. You have to first find V1, then you will have to find V2. Please note V2 is between these corner terminals here. Okay, so first let us find V1. To find V1, you have to travel along the outside loop. So let's start traveling from this point. So it is 10 volts and then minus V1 and then plus 6 volts, then minus 2 volts, then minus 3 volts will be equal to 0. So 10 plus 6 is 16, 16 minus 5 is 11. So minus V1 will be equal to minus 11. So V1 will be equal to 11 volts. Okay. So V1 is 11 volts. Now, if you want to find the other unknown parameter, V2, so please note V2 is between these corner terminals now. Now, how will you apply KVL list? You can use this particular loop. Starting from 10 volts, you can travel along this and then you can travel through this virtual loop and then you can end like this. So if you travel that way, it will be 10 minus V2 minus 3 will be equal to 0. So 10 minus V2 minus 3 equal to 0. So V2 will be equal to 7 volts. So by this way, you can apply KVLs. Next problem. You have to find what is V1. You have to find what is V2. You have to find what is Vx. Immediately you can say what is the value of V1? V1 value will be equal to V1 here. Anybody? Anybody? What is V1? V1 will be equal to 0 because there is no current that is flowing along this particular loop. So V1 is 0. So now what is Vx? Vx is between the voltage between these two terminals. So you can apply KVL along this outer path like this. So which means it is plus E1 or plus 50 minus current multiplied by 3.3K, which is the drop across this, and then minus Vx equal to 0, right? So which means you need to determine what is the current in this particular loop. So if you want to find the current in this loop, what you need to do is, to find current, you will have to apply KVL in this loop to determine what is the current here. So it is again 50 minus I multiplied by 3.3K plus 4.7K plus 10K minus 30 equal to 0. So you can, from this you can determine what is the value of current, and that current you can substitute here. So I'll give you the solution. So V1 is 10, right? So V1 here it is 10 because there is no current that is flowing across this, for the simple reason this terminal is open circuit. This terminal is open circuit. Now V2 you can determine. So what is that? You can apply KVL in this loop again. So it is 10, this particular resistor multiplied by the voltage difference, the sum of all the voltages in this loop, which is 50 minus 30 divided by all the resistances, which is 10, 4.7 plus 3K. So it is 11.11 volts. So it is 11.11 volts is the V2 voltage. And similarly, Vx, if you want to find out, as I said, it is E1 minus voltage across 3.3K. Now, voltage across 3.3K, you can find out by applying Kirchhoff's, by applying voltage divider rule, right? So, you know what is your, okay, voltage across 3.3 is nothing but this value of resistor 3.3K multiplied by, it has to be 50 actually. So it has to be, okay, so either you can apply this voltage or, yeah, it is correct one. It is actually 50 minus 30, which is 20, is what is the total voltage that is applied across this 3.3K. Hence, it is 20 volts divided by all the sum of all the resistances in series. So 3.3 plus 4.7 is 8, and 8 plus 10 is 18. So it is 18K. So voltage across this is 3.57. So 50 minus 3.67 will be the voltage across Vx, right? So which is 46.33 voltage. Now you can cross verify also. You calculate what is the voltage difference across 4.7. So it is 4.7 multiplied by the voltage difference in this particular loop, which is 20 divided by 18K. So this particular value will be, what is this value? Is 4.7 multiplied by 20 divided by 18. 4.7 multiplied by 20 divided by 18. So which is 5.22 volts, right? So now if you add, it has to be 46.33 volts. So what is that? 30 plus 11.11 is 41.11. So which is 41.11. So if you add, so it will be close to 46.33 volts. Right? So I'm just adding the voltage drop of these things, which must be equal to this Vx voltage. So that's what I did. So now take this particular circuit and find the value of R. Okay. So in this particular circuit, if you see, it's simple. How do you find? You apply, you can determine what you can apply voltage divider rule. So that's the simplest way you can find out. So your voltage between these two terminals is 100 multiplied by, so what is this 100 voltage equivalent to? It is voltage between these 2 points. So this 2 point is nothing but your source voltage 140 multiplied by these two resistors 6 plus R divided by 6 plus R plus this 3 mega ohms. You are applying voltage divider rule. You are applying voltage divider rule. So which will be equal to, so just to rearrange this equation. So 100 multiplied by 6 plus 9, 6 plus 3 is 9 plus R. So 9 plus R equal to 140 multiplied by this is 840 plus 140 R. So just to rearrange this and you can determine the value of R, which is 1.5 mega ohms. Any doubt? Okay. Now let's find single script value voltages VA, VB, and VAB. So what is VA here? If you want to find VA, as I said, you have to draw something like the potential, the battery you can draw like this, and then you put a ground. So this will be VA or VA0. You want to find VA, you can apply KVL in this loop. So what is the voltage? It will be VA minus 12 and minus 5 equal to 0, and VA will be equal to minus 17. VA, it's VA equal to plus 17, right? So VA is equal to plus 17. Now you have to find VB. You want to find VB, just simple, put a voltage source here, battery here, and then apply KVL in this loop. If you apply KVL in this loop, it is plus 5, plus 16 minus VB equal to 0. So VB equal to 16 plus 5, which is 21 volts. So that will be the value of VB. Now VAB, you need not calculate this way. You just know VA and you know VB. VAB is nothing but VA minus VB. So it is 17 minus 21, which will be 4 volts. Another example. For this particular problem also, it is the same. If you want to find VA, VA is straightforward actually. If you look, what is VA? VA corresponds to this complete line. VA corresponds to this line. So which means VA is same as that of your 14 volts. VA, so this is also VA. This is also VA, which is nothing but VA will be equal to this 14 volts. Now what is VB? VB, you can just put a voltage battery like this and then apply KVL in this loop. Let's start from here. I'm going to travel like this and then I'm going to travel like this, right? Yeah. So what is this voltage? It is plus 14, which is plus 14, and then it is plus 6, and then plus 10 minus VB equal to 0. So VB is equal to 30 volts, right? So let's see the answer. Yes, VB is equal to 30 volts and VA is equal to 14 volts. VAB is 14 minus 30, which is minus 16 volts. Okay. Now let's look at the third problem. Third problem, you need to find VA. What is VA? And you need to find VB also. VB is very simple and straightforward. VB is this voltage, right? So which is minus 8 volts. Now if you want to find VA, it is this voltage. It is this voltage. It can be drawn with a battery like this and then a ground potential, which is VA here. and apply KVL in this loop. And this 10 volts can also be drawn like this with a battery. So this is 10 volts. Okay, now apply KVL here. So it is 10 plus 3 minus VA equal to 0. So VA will be equal to 13 volts. So VA is 13, VB is minus 8, and VAB you can find out 13 minus of minus 8, which is 21 volts. All right. Now, again, let's find out the different values of VA, VB, VC, and VAB. So if you look at B and C part, it is straightforward because once you know VA, VB, VC, and VD, you can use these voltages in determining these double script values. So let's focus towards determining the single script values. That is VB. VB is straightforward because VB is what? It is this voltage. So VB is 14 volts, right? And what is VD voltage? So VB is 14. VD is this voltage between this and ground terminal, which is 0. So VB to start with is 14 and VD is nothing but 0 volts. Okay. Now what is VA? VA can be, the circuit can be redrawn. The circuit can be slightly redrawn like this by putting a battery source only, nothing else. Is putting a battery source like this and applying KVL in this loop. So it is the equation will become VA plus 8 minus 14 will be equal to 0. So VK will be equal to plus 6. VA will be equal to plus 6, right? So VA is plus 6 volts. VA is plus 6 volts. VC, we just, we didn't find out VC. VB is 14, we found out, and VD is 0 volts. Now we need to find out VC. You want to find out VC, right? You need to find out. So I can travel. It will be like I'll be putting a battery like this. I'll be putting a battery like this, and this voltage is VC. I will have to apply KVL along this loop. KVL along this loop. So starting from this, so it will be minus, and I need to know the drop also. I need to know the drop across this. So if I need to know the drop across this, I need to know what is the current flowing through this particular path. So if I need to know the current flowing through this path, before applying KVL along this loop, I have to apply KVL along this loop first. I have to apply KVL along this loop to determine what is the current flowing across this. So if you apply KVL along this loop, so it is 14 plus 6, right? So this is also negative and positive I'm encountering. As I travel here, I'm encountering a negative and positive across 6 also. So it is 14 plus 6 divided by 10 plus 10, 20 will be your current that is flowing across this branch. So it is 1 ampere. So 1 multiplied by 10 will be 10 volts here, right? So 1 will be 10 volts. So, and you can apply KVL in this loop. So VC is nothing but this, you apply KVL, it is minus 6 and then minus 6 plus drop plus 10 volts minus VC equal to 0. So VC will be equal to 10 minus 6, which is 4 volts. So by this way, you can determine what is the individual voltages. Now, once you know VA, VB, VC, and VD, the all other parameters are straightforward. VAB is VA minus VB, VCB is VC minus VB, VCD is VC minus VD, and so on. Similarly, VAD and VCA is nothing but VA minus VD and VC minus VA. So once you know these 4 voltages, you can easily determine these 2 voltages. Now, coming to the next circuit, this kind of circuits, you have to determine the value of R1. You will have to determine the value of R1. So how do you do this is, if you look at this circuit, all the resistors are parallel. All the resistors are in parallel, right? How are they in parallel? Look at the top, this particular portion. All these are shorted resistances. right? And similarly, the bottom resistances, if you see all the other branches, they are all shorted only. So if you want to redraw this particular circuit, you can simply redraw like this. That is, I have R1 here, right? I have R1 here, and to both the ends of R1, I have this 24 ohms also connected, right? This 24 ohms also, they are connected. This 24 ohms, they are also connected. So I can put this 24 ohms here. And similarly, this 24 ohms also, it is in parallel. 24 ohms, they are in parallel. And similarly, this 120 ohms, this is also in parallel. So all the four resistors, they are in parallel only. This circuit can be redrawn like this. Slightly, if I put a resistor, if I put, yeah. So if I just simply put a resistor here, then this parallel concept will go away, right? So you might get problems later on where you will have resistor across all these branches also, here, here, and then here. It will be like a cube, right? So you might expect such kind of problems also. You have to find out what is R1. In that case, it is slightly different. Okay, now let's focus towards this problem. So you can see first 24 and 24, they are in parallel, right? So 24 parallel will be 12 ohms, and the 12 ohms will be in parallel with 120 ohms, right? So 12 ohms will be in parallel with 120 ohms as well as with R1, and whose equivalent resistor is given to be 10 ohms. So your RT is given to be 10 ohms here. So it is 1 upon 10 will be equal to 1 upon R1 plus 1 upon 12 plus 1 upon 120, which means R1 is equal to 120 ohms. So you can simply solve this and determine the value of R1. Now coming to this circuit, you have to determine the power dissipated
Excuse me, sir.
across. Yes,
So
yes, yes.
why isn't it shorted in the first question?
Okay. Why it is shorted is if you look at all these lines, right? They are just a simple lines only, right? There is no resistance in between. Look at the top portion of this, right?
Yes, sir.
All these are shorted. Similarly, all the bottom lines are also shorted. You don't have any resistance across these lines. So if you visualize it like a cube, it will be like this 24 ohms, one end is connected to this 24 ohms, other end is also connected to this. Now let me take another color and draw for this 24 ohm. I'm going to draw for this 24 ohm. One end is again connected to this, and other end of 24 is also connected to this. Now let me draw for 120 ohms. Yeah, purple. 120 ohms. You see, this line is also connected to this line, and then this 120 ohms is also connected to this. So which means all these four resistors, they are all connected in parallel. That's why we drew the equivalent circuit that way. Now
But sir,
clear?
isn't it like a square? I mean, what it looks to be is a
It
square
is
of a wire, right?
square. It is square,
So the
but they don't have
should
any internal resistance.
so shouldn't the current just enter, loop around, and then come
No,
back from the
that's
same
what I
terminal?
said. Never, I mean, you have to come out of your class 12 way of thinking how the current gets divided here. Don't think from the current gets divided point. You will have to, there is one such problem where you have to think from the current division point. And when you are getting such kind of circuits, you are not at all applying any currents. Even, okay, let me tell you, even if the it is all about the magnitude of the currents. You are very right. If the current goes here, the current in this branch and in this particular branch, they will be equal when compared to this branch. And the same current that is coming here, all the currents, there will be no more currents that will be flowing here because this line is shorted. So if you look from current's point of view, your current will keep circulating like this, right? It will come and
Yes, sir.
stand here, and it will be keep circulating like this, and it will be shorted actually. But still there will be small amount of currents that will be flowing. That's why, if you think from current's point of view, you will get confused. You will not be able to solve. That's why I said come out of that thinking ability of how you apply a voltage and what will be the current. So don't come out of that way of thinking. Just look whether you have any resistance in the circuit. Based on that, you start combining the parallels and series resistances. Okay. All right. Now, you have to find out what is the power dissipated from this particular battery. If you want to find, please note it is a DC power that has been asked. We are studying only DC voltages only. So power DC is nothing but voltage, DC voltage multiplied by the DC current, which means you know that VDC is 60 volts. You have to find out what is the current here. If you want to find the current, you need to find out what is the equivalent resistor. So what is equivalent resistor is, you see here this 12 ohms and this 20 ohms, they are in parallel because they are all, both the arms are connected. Both the arms are connected. Similarly, this 2 ohms and 8 ohms, they are in series and their equivalent will be in parallel with this 20 and 12. And 5 ohms is in parallel with this 20 and 12 and this series combination. So you can redraw your circuit something like this. That is, you look at this is 60 ohms, you have this 60. And then 5 ohms here, you have the same 5 ohms. 2 and 8 in series, 2 and 8 in series, 20 ohms in parallel and 20 ohms in parallel. So this parallel combination 20 parallel 12 is 7.5 and 8 plus 2 is 10. And this combination 5 and this combination is 3.3. And if you find the total equivalent resistor, it is 2.31. It is 2.31 and you have to find, you can determine what is the current here. So 60 will be equal to, so you need to find out current, right? So I will be equal to 60 upon 2.31. Let me calculate. So it is 60 upon 2.31 is 25.97 is the current that is coming out. 25.97 is the current coming out. So this current multiplied by voltage. So what is voltage multiplied by 60 will give me the power. So multiplied by 60 will give me the power, which is 1558 watts. So the power that I get by calculating this way is 1558 watts. Right? So which is equivalent to 1.56 kilowatt. Okay. Now let's move to these kind of problems. You have to determine all the unknown voltages and unknown currents. It's very straightforward. The short circuit, you have to find out what is the short circuit currents I1 and I2. First thing is, let us find out what will be V1 voltage. V1 will be equal to 0. For the simple reason, your current that is coming here will bypass this, and this 6 ohms will have no effect. Similarly, I2 current will be 0. Why it will be 0 is because this terminal is open. So whatever is the source current is, it will not go through this. It will not go through this for the simple reason they are shorted. Now, if they are shorted, all the currents will flow, but the trick here is the end is open now. So no current will flow, though it is shorted here, right? So that is the observation that you need to make. Now, okay, now what is this particular current I1? Since there is no current flowing through this part of your circuit, there will be no current through this part of your circuit also. So literally, this part of the circuit has no meaning at all as far as the current flowing is concerned, as far as the source current is concerned. So now what is 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 20 divided by 4, which is 5 ampere, right? 20 by 4 is 5. So 5 ampere is the source current, and that is same as that of your I1 current also. For the simple reason, your current will flow only through this direction. And even if it comes here, it will flow only through this direction. It will not flow through this direction for the simple reason this is shorted, right? So you have found out what is I1, which is 5 ampere, and I2, which is equal to 0 current because V2 is open circuited terminal. Now, what is V1 voltage? V1 voltage will be 0 because the 6 ohms is across a short circuited line. So V1 will be equal to 0. Now, what is V2? V2, anybody? Can you tell me the answer? What is V2? What is V2? V2, okay. is same as that of this potential, right? V2 is same as that of this potential. Why? Because no current is flowing through this, no current is flowing through this, so there will be no drop across this, there will be no drop across this, so V2 will be equal to 20 volts, right? So source current we have already found out, which is 4 ampere. So let me find out. So 20 by 4 is 5. Yeah. So I1 is 5 ampere and I2 is 0 ampere, as I said. And V1 is 0 voltage because it is across I1. 1 minute, Prithvi. And V2 is same as that of this voltage, which is 20 volts. And IS is equal to I1. Yes, Prithvi.
So I don't quite understand how V2 is 20 volts. So like in the previous question, we attached like imaginary batteries and we continued the circuit, connected them to ground, and then
Yeah.
found out the voltage. So why don't
Yes.
we do the same here?
It is about, see, if it is not about, it is about voltage. It is not, even if you put a battery, it is an unknown battery, right? It is only our
Yeah.
assumption that it can be viewed like this. It is not, but in the actual circuit, they are an open circuited terminal, right? It is
All
for
right.
our understanding to explain what V2 will look like. Okay, so it is a
So
virtual assumption only that we are putting a battery and imagining to apply KVL, like in the previous cases. But here, if you see, if you want to find V2, it is a terminal voltage, right? So this end is open. You need to find out the voltage across this. If you want to find the voltage across this, if you apply KVL, so it is 20 minus drop across this minus drop across this will be equal to VT. But the problem in this case is since the terminal is open, you don't have any drop here because the circuit is not closed. So there is no drop across 10 or no drop across 5. So the drop across this will be 0. The drop across this will be 0 volts and the drop across this will be 0 volts. That's why I said V2 will be same as that of this 20 volts only. Okay.
all right, so understood. Understood.
Okay.
Yeah.
Now let's take another problem. Yes. This problem. I'll give you some time to think. So what is this circuit is you have to find the equivalent resistor at this point. And this is an infinite ladder of resistors. Infinite ladder of resistors, it goes to infinity. Now, how will you solve such kind of problems? Okay, one way is if this is the equivalent resistor, and if you remove this particular, this goes to infinity also, right? If you remove this particular part, and now you look at this particular position, still it is an equivalent resistor RT only, right? Likewise, equivalent resistor RT can be viewed at all these positions towards an infinite time. So how you can do this is you can slightly redraw the circuit, something like this. What is that? I have this RT here, 1 ohms, same 1 ohms, 1 ohms here, 1 ohms here, 1 ohm. And now I'm going to view this, the rest of the part of the circuit as one more RT, right? Now having this, now it is, now if I simplify, this RT plus 1 will be in series and that combination will be in parallel with 1, which will be equal to RT. So I will be getting a quadratic expression, right? So RT is 1 parallel to 1 plus 1 plus RT. So which is nothing but 2 plus RT. So RT will be 1 multiplied by 2 parallel RT, 2 plus RT upon 1 plus 2 plus RT, which is 2 ohms plus RT upon 3 ohms plus RT. You just cross multiply it and then what you get is a quadratic expression. RT squared minus 2 RT minus 2 equal to 0. Now this can be solved by your regular second expression minus b plus or minus root of b squared minus 4ac by 2a. So when you substitute, what you get is the two answers you get. One is 0.732 ohms and other is minus 2.732. So you cannot have any negative resistor, negative value as a resistance. So the actual answer is RT is 0.732 ohms. And this is logically also right. Why logically right? If you look at this, 1 ohms is the parallel combination with the rest of the ohms, rest of the part of your circuit. So which means 1 ohms is the, and this particular part 1 plus 1 plus something will always be a larger quantity than 1, which will be in parallel with 1, and your total equivalent resistor must always be less than the least values of resistor in the parallel combination, which is 1 ohms. So RT, which is 0.732, is the right answer. And even if you remove this to be 2.732, this is not logically a correct answer. 2.732 cannot be an equivalent resistor for this parallel combination, right? So hence 0.732 is the actual right answer. Okay. Now let's consider this circuit. You have to determine, it's straightforward actually. You have to determine RT. Okay. So RT, it is very simple. How you do this is, it is R1 and R2, they are in parallel. So it is 10 inverse, 15 inverse, and its answer inverse. And these two will be in series. So I'm having the calculator. Let me do it. So it is 10 inverse plus 15 inverse, and its answer inverse, right? And that inverse plus 12 inverse and its answer inverse. The equivalent resistor is 4 ohms, right? So from the way I calculate, it is 4 ohms. Okay. Okay. Now what else is asked? Now IS is asked. Once your equivalent resistor, you know, it is 4, and your applied voltage is 36. Your current, your RT is 4. So this current has to be 9 ampere. This has to be 9 ampere. So it is 9 ampere. Now what else is asked? I1 is asked. Now you know, if you know this current, please note, this is 9 ampere. You need to find out I1. So you can apply current divider rule, that is 9 multiplied by the opposite resistance, which is 10 plus 2 is 12 volts. Yeah, 10 plus 2 is 12, and then divided by 12 plus this parallel combination. That is one way. Other way is, you know, the voltage, this to be 36. 36 divided by this equivalent resistor, which is 6 ohms, right? So RT, which is R1 parallel R2, is 6 ohms. So 36 by 6, which is 6 ampere. So if this is 6 ampere and the total current is 9 ampere, this has to be 3 ampere, right? So 3 ampere. So you have found out IS, I1 and I2. And what is IA? IA is voltage across R4. Between this point and this point, voltage across R4, and you know that 3 ampere current is flowing. So 3 multiplied by 2, which will be 6 volt, will be the voltage across this. If this is 6 volts and you have 36 volts, the voltage across this will be 30 volts, just for the sake of calculating. So it is 6 volts. Now, okay, another type of problem. VA. Okay, so you have to find what is VA and VB. Again, for all this, you have to, yeah, how will you find VB is, you can apply Kirchhoff's voltage divider rule for this particular circuit. What is VA? VA, so this is 32 means all this particular line is also 32, right? So which means VA is voltage across 72 ohms. So VA is also equal to 32 volts. It's also equal to 32 volts, right? Yeah. The circuit can be slightly modified like this. Yeah, it can be modified like this. So which means this 32 volts is same as that of this VA also. Now VB, where is VB? VB is the voltage across this. Okay. So, and you can apply voltage divider rule still. So it is between this particular point and this point. So this resistor is 8 ohms. So it is source voltage 32 multiplied by 8 volts divided by this combination. Yeah, we cannot put this combination, right? So you have to find the equivalent resistor between 24 and 8, and then you have to find out the 12. Yeah, so 24 parallel 8. So what is 24 parallel 8? The equivalent value is 6. Okay, so this is 12. This equivalent is 6. This equivalent is 6 ohms. So 32 multiplied by 6 divided by 6 plus 12 is 18. So 32 multiplied by 6 by 18, it is 10.66 is the voltage between, is the VB term voltage. Let us say 10.66. Yes, right. So VA, as I said, is this voltage, and VB is this particular voltage. And how do you find that? This 8 parallel 24 is 6. So 6 multi-voltage divider rule, 6 multiplied by 32 divided by 6 plus 12 is 10.67 volts. Now I1, you want to find I1. Yeah, you know the total voltage, by the way, right? So VB is 10.67. So if this is 10.67, so the total voltage between this point and this point is 32 volts. 32 divided by 12 plus 6, 18 will be the current that is flowing across this branch, right? So 32 divided by 18 is 1.77, which is the total current I1. So 32 divided by 12 plus 6, because this voltage divided by the total resistance in this branch is 32 divided by 18, 1.78 amps. Now you need to find out IS. If you want to find out IS, then you need to find out what is the total equivalent resistor of this. So this parallel combination is 6. 6 plus 12 is 18. So 18 parallel 18 is 9. So what is 9 parallel 72? So 9 parallel 72 will be 8.12 ohms. So that is the equivalent resistor. Once you know the equivalent resistor, 32 by 8.12 will be the source current IS, which is 3.94 ampere. Okay. So this is how you solve this. Let's take another problem here. You have to determine the current I. Okay, so how will you solve? First, you have to find out what is VA and VB also. Look from the outside. So what is VA? If you want to find VA also, you need to determine the drop across this, right? So 20 minus drop across this will be equal to VA, right? And how do you find I1? You want to find I1 means you have to find all the equivalent circuit of this. And I1, the current gets divided into like this, and then further it gets divided like this. So you want to find I1, it is like, yeah, let us find the equivalent resistor now. 6 parallel 6 is 3, and then 3 plus 3 is 6, and then 6 parallel 3 will be approximately 2 point something, and that will be in series with 3. That will be the value of the total equivalent resistor RT, right? So, okay, let me give you the value. 6 parallel 6 is 3. 3 plus 3 is 6, right? So 6 inverse plus 3 inverse and its answer inverse, which is 2, will be the equivalent resistor of this particular part, which is 2 ohms. And 2 plus 3 is 5. So 20 divided by 5, which is 4 ampere, will be this current. So RT here is equal to 5 ohms. Right? So I is nothing but 4 ampere. How did I do? I just found out the equivalent resistor RT. 6 parallel 6, which is 3. 3 plus 3 is 6. 6 parallel 3 is 2. And 2 plus 3 is 5. And 20 divided by 5, which is 4 ampere. That's how I found out I1. Now I2, how can you find this? You can either apply, multiple ways are there. You can find out what is the current across R4 by applying current divider rule, and then you can subtract the total current I1 minus this to determine I2. So that is one way. Other way is, other way is you can apply current divider rule for I2 itself. So what is I2? I2 will be the source current I1, which is 4 ampere, multiplied by the opposite resistance, which is R4, divided by R4 plus this parallel combination. This parallel combination, we just saw what is that? It is 3 and 6, right? So it is 3 plus 6, which is 9, which is 3 plus 6, which is 9. So the source current is 3 multiplied by 4. So 12 ampere, 12 divided by 9, which is 1.33 ampere, is the current I2 is. So if I2 is 1.33, again you can apply current divider. And other reason, okay, other way is both the resistors are same. So obviously the current has to be divided equally. So 1.33 divided by 2, which is 0.67, is the I3 current also, right? So you have found out I1, you found out I2 and I3. Now, once you know current, you can easily determine what is VA. What is VA? It is the voltage drop across this, right? So voltage, yeah, I multiplied by 3 ohms. That is this current flowing through this multiplied by 3. Now, what is this particular current? We know I2 is 1.33 and the source current is 4 ampere. This is 4 ampere and this I2 is 1.33. So the remaining how much? 2.77 must be this particular current. 2.77 multiplied by 3 will be the 2.767 multiplied by 3. 8 volts is the voltage VA. Okay. And VB also, it is similar. It is VB is nothing but yes, it is I3. You know the value of I3, you just calculated 0.67. 0.67 multiplied by 6 will be the voltage, which is 4 volts. Now, if you add all the voltages, they will be same. That is, this voltage is 4, right? We just calculated. So 4 and this current is 4 also. This, so 12 volts here. And I2 is what? I2 is 1.33 multiplied by 3, which is approximately 3.99, which is close to 4. So 12 plus 4 is 16. 16 plus 4 is 20, which is what is your applied voltages. Okay. So this is how you quickly cross verify whether your answer is right or wrong. Next, how do you solve this? Okay. Now, to determine this, you have to first determine what is the current I. To solve this, you have to apply Kirchhoff's current law at this node, right? Why at this particular node is because if I know the voltage between these two terminals, which means I can determine what is the current across this, and I know what is the current across this. And once I know the current across this, I can apply KVL in this loop. So, and in order to first find this particular current, because I do not know what is an unknown voltage is. So what I do is, and the current direction is already given here, right? So let us presume the same direction also. So if you apply KVL in this loop, you can easily determine what is the current across this. So if you apply KVL, I'm not traveling in this direction, okay? I'm traveling in this direction. So it is plus 18 plus 20, which is 38 volts. 38 divided by 8 will be the current flowing in this particular loop, right? So yeah, so this is flowing in the counterclockwise direction. So the current across, yeah, so 18 plus 20 minus voltage V80. So V8 is 38 volts. So and the current across it is 38 divided by 8. So this particular current flowing through this one is 4.75 ampere, right? It is 4.75 ampere. Now, if this is 4.75 ampere, now how do you find the current across this? Again, you can apply KVL in this loop also. In this loop also, you can apply KVL. So it is 18 divided by 6 plus 3, which is 9. So 2 ampere is the current flowing through this. So through this, it is 2 ampere, which is the current flowing through this. And now you can apply KVL across this particular point. So KCL. So it is 4.75, which is the current entering, and 2 ampere, which is the current entering, must be equal to the current leaving. So which is 6.75 ampere is the current that is coming out of this battery. That's what is asked, right? Yeah, you're being asked about open circuit voltage also. Now, open circuit voltage, it is straightforward. It must be either 20 volts multiplied by this particular drop. You know what is this current, right? It is 2 ampere. Whatever is the current flowing through this will also flow through this also, right? Because this end is open. So no current will flow through this. So if this is 2 ampere, and what will be the drop occurrence is 12 volts. And the direction of flow of current we assumed was this. So it will be plus and minus here, right? Plus and minus, it is 12 volts. So it has to be 20 plus 12. So it has to be 32 volts is the total drop. Let us see. Yeah, it is 32 volts. Either you can apply KVL, that is this voltage plus this voltage you can do, or this voltage plus this particular voltage, that is also fine. In this particular case, I think, yeah, first approach is maintained. So I3 multiplied by 6 plus 20, which is 32 volts. Okay. And what is what? Yeah. Yes. You can verify again also that it is 6.75 ampere. Now for this particular side. So just understand this particular problem for 2 minutes. How will you find I, I4, I6 and I10? This is a very simple, straightforward problem. Okay. Now, if you want to find out I1, So, and you have voltage, you definitely require the total equivalent resistor. Please note, this wing is parallel with this wing, which is also in parallel with this particular wing also. What does this mean? This 2 and 2, they are in parallel. R11 and R12, they are in parallel. So 2 parallel is 1, right? And this R10 is also 1. So this is 1 and this is 1. There are 2 ohm resistor in series, and you are, because I need to find out I10. You want to find out I10, then it is 12 divided by 2, which is 6 ampere will be the value of I10. Just to start with, I don't know. Yeah, the solutions are there. I don't want to jump here. Okay, I'll just display the solution and then I'll speak. Yeah, as I said, 2 and 2 parallel, I will get 1 ohms here, and then this 1 ohm and 1 ohm will be in series. So the total current in this particular window will be 12 divided by 1 plus 1, which is 2, which is 6 ampere. So I10 will be 6 ampere, which is calculated. Okay, now coming to, yeah, let us find out what is the equivalent resistor now, right? Once I find the equivalent resistor, then I will try to find out what is I4 and I6.
Sir,
Now, what is, yes.
sir,
Yes,
the
yes.
two R8 and R9 are shorted.
R8 and R9, they are in series. They are not shorted. They are in series.
Sir, in front of them there's a
No, sir, they'll be shorted out.
Yeah. You are right. They are shorted. So they will not have any value in the circuit at all. Yes. Yeah. So because it is shorted here, as rightly pointed out, it is shorted here, right? So this resistor will not be in the picture at all. Okay, let us find the equivalent resistor. You can use calculator. As we speak, you can give the values. 6 is in parallel. 6 is in series with 4, so it is 10. 10 is in parallel with this R4 10, so it is 5. 5 will be in series with this 1, which is 6. 6 is in parallel with this 6, it is 3. And this 3 is in parallel with this 3, it is 6, right? So in this window, the equivalent resistor is 6 ohms. In this window, the equivalent resistor is 3 ohms. In this window, the equivalent resistor is 1 plus 1, 2 ohms. So it is 2 ohms. Here it is 3 ohms. And it is 6 ohms is what is the equivalent resistors. Now, what is 6 parallel? Somebody, 6 parallel, 3 parallel plus 2 parallel, and its answer inverse parallel. So it is total equivalent resistor that I get is 1 ohms. I think it is right. So where is RT? Yeah, RT here, it is 1 ohms. Yeah. So it is 12 by 1, which will be 12 ampere will be this I value of current, which is 12. So we have already found out I10. Let's find out I4. All right. So what is the equivalent resistor that we got in this particular branch? It is 6 ohms that we got in this window, right? So 12 divided by 6 will be 2 amperes will be the one that the current that is coming out from this, right? So this will be 2 ampere. It is 2 ampere. And that 2 ampere gets equally divided because this is also 6, this is also 6. So if it gets equally divided, so it is 1 ampere gets divided here. So 1 ampere comes here, right? So it is 1 ampere. And this 1 ampere further gets divided equally also because this 6 plus 4 is 10 and 10. So it is 0.5 ampere is I4 and I6 is also 0.5 ampere, right? So I4 is also 0.5 ampere and I6 is also 0.5 ampere. All right. So these are some of the kind of problems that you can try. Now, okay, maybe the last problem before we wind out. You have to find out RT and you have to assume that each values of resistor here is 10 ohms. Okay, assume that each resistor is 10 ohms and you have to find out the total equivalent resistor RT. Now, since we have not taught you a circuit simplification technique called as star to delta and delta to star, without knowing that particular technique, if you want to solve such circuit where no resistor is in series or they are in parallel. They are neither in series, they are not in parallel. If you look at this point, 3 resistances are dividing. You take this point, 3 resistances are dividing. Any corner you take, there are 3 resistances where you cannot tell that they are in series or they are in parallel. So under such circumstances, you can go back to your class 12 technique. What is that is? You have to assume a current that is flowing, right? Now, what is my objective, right? If you want to find RT, right? If you want to find RT, I need the total voltage in the circuit that is applied and total current in the circuit, right? So E upon I need to find out. Now, if I assume if my current I becomes a known quantity, then my objective will be to determine E to find out RT. So what I'm going to do here is I'm just going to assume that this particular current is just 1 ampere, right? I'm just going to assume that this is 1 ampere. Now, please note, every values of resistor is 10 ohms. So this is 10, this is 10, this is 10, this is 10, and all the values of resistors are 10. Now, I have to be slightly smart enough here. I need not look at the other branch of my circuit at all. Why? For the simple reason, if I have assumed that my total current IS is 1 ampere, so this is 1 ampere here. It will come in the denominator, right? So this has become known quantity. Now I need to find out E only. Now what is E? E is between these two terminals. E is between these two terminals. If this is between these two terminals, I have to be smart enough here that this E here corresponds to the sum of drops across this branch plus this branch and this particular branch. So which means I am just looking at the loop that completes this particular path, right? So this voltage is what is my E. You can take any path also, it will be the same, right? After completing this, I'll show you the other parts. Okay, so now if that is the case, now if please note, this is 10 ohms, this is 10 ohms, and this is 10 ohms. If my current is 1 ampere, then what will be the current across this branch? What will be the current across this branch? And what will be the current across this? 1/3 of my current will come across this, right? And 1/3 will go here, and 1/3 will go here, right? I'm not interested in what happens beyond this. So 1/3 of the current comes here, and then further it gets divided into two branches, right? So here 1/6 of my current will flow because 1/3 divided by 2, 1/6 of my current, and here again 1/6 of my current will flow. Okay, now this 1/6 of my current is coming here, and what will because I'm interested in this drop and this particular drop. I'm interested in what is the current going to flow across this 1/6 current here. Let us see what happens here. So 1/3 of the current is entering here, and that also gets divided into two. So 1/6 of the current will come here, and 1/6 of the current will go here. So 1/6 of the current comes here, and then 1/6 of the current is already here. 1/6 plus 1/6, so 1/3 of the current will flow across this. Okay, now I have everything what I require. So 1/3 multiplied by 10 ohms resistor. So 10/3 will be the voltage drop across this. So 10/3 will be the voltage drop across this resistor. Now 1/6 of the current flows here, and 10 ohms is the resistor. So 10/6 is the voltage drop across this resistor. And across this resistor, it is 1/3 of the current flows. So 10/3 will be the drop across this. So now what is E? E is nothing but 10/3 plus 10/6 plus 10/3 will be the voltage. So 20/3 plus 20/6. So which is approximately, let me give you. So which is coming here, it is 10/3 plus 10/6 plus 10/3, which is approximately 8.33 is the voltage. Now, once I know 8.33 here, once I know that it is 8.33, my total resistance will be 8.33 by 1, which is 8.33 amperes, ohms, will be the value, what it will be the total equivalent resistance value, right? So this is the same circuit that I said you. Same. See here, 1 ampere flows. It gets divided into 1/3, 1/3, and 1/3. And this 1/3 gets divided into 1/6 and 1/6. And this 1/3 gets divided into 1/6 and 1/6. And this 1/6 and this 1/6 combined together to form 1/3 here. And then you can find out what is the total voltage here. And then based on that, you can find out what is the total equivalent resistance, right? All right, so these are some of the, I took few important exercise problems from your textbook and then we try to solve. Any doubts so far? Yes, Prithvi.
Sir, can you please upload this PPT on Blackboard?
Yeah, the recording will be immediately available after this and then I will upload. Yes.
All right, sir. Thank you so much.
Okay, then we'll stop the class here and you can leave.
Sir?